Professor Brian Ford is a retired microbiologist and was responsible for introducing the biohazard law, which governs the safe handling of viruses, which has been adopted worldwide.
I had a really fascinating chat at the end of last week with respected biologist, BBC broadcaster and author, Professor Brian J. Ford.
Well, it is the future, according to my next guest, Professor Brian Ford.
Well, joining me now from Cardiff is Professor Ford.
Well, Professor Brian Ford, who made those comments, is live on PM.
Truly unconventional scientific career. Biologist and lecturer Dr. Brian J. Ford.
I have Brian J. Ford. He's a very prolific research scientist who launched major science programs for the BBC. His books have pioneered new approaches in bringing science to the public. Over 130 editions of his books have been published around the world, and he appears in TV programs all over the world.
You're listening to Zen Sandwich, a podcast for the independent mind and anyone who embraces life despite its absurdities. Join former attorney and professor-turned-Japanese papermaker Mark Reid each week as he talks with creative, inspiring, and influential people, or as he shares his own research to help make your world a little better today than it was yesterday.
Hey, here we are. Well, I promised my audience even bigger names in my second year of the Zen Sandwich podcast, and I'm very proud to say I am delivering on that promise right from the start. Professor Brian J. Ford is an independent research biologist, primarily but not exclusively in the area of microbiology. The relevance of me pointing that nuance out will make a little more sense later. He's been a lecturer and an author of over 30 books, as well as numerous chapters in other books and a vast array of scientific articles in journals, including Nature, New Scientist, Scientific American, and the British Medical Journal. He's a prolific writer and researcher. He's written for The Times, The Daily Telegraph, and The Guardian. He's been a broadcaster himself, hosting programs including Science Now and Kaleidoscope for BBC, and has been interviewed by the BBC on numerous occasions on topics ranging from World War II to the current pandemic. He has been a media personality for over 40 years. He was appointed visiting professor at Leicester University, a fellow at the Open University, a fellow at Cardiff University, president of the Society for Application of Research at Cambridge University, among numerous other accolades, honestly too many to name them all. But, dear listener, be forewarned, Professor Ford is not without his share of controversy or beyond the reach of criticism. We will approach that topic as well. He joins me now from Cambridge to talk about truths we accept which just aren't true. Professor Brian J. Ford, welcome to the program.
Nice to be here. Konnichiwa.
Konnichiwa. Well, Professor, I would like to cover several topics in our limited time, so we may jump around a bit, but I want to dive right in first with one that I know you have an opinion on and is on all of our minds and in the headlines every single day these days, COVID-19. One, how are we handling it? Or, well, how are you handling it how is it being handled in Britain? I should ask where you are. And two, is there anything we should have done differently? How should we tackle the next pandemic?
I can certainly explain that. Everybody's told to wear masks, and the Royal Institution lectures that they have broadcast on the BBC at Christmas every year, they actually looked at face masks this year. And it was the most appallingly dishonest broadcast I have ever seen. They showed particles being trapped by a mask, where the particles were thousands of times bigger, and the entrapment was completely misleading. And then they showed how electrostatic charge might possibly hold on to viruses. So they had a Van de Graaff generator creating perhaps 50,000 volts, attracting little beads of polystyrene, and said, this is what happened. It doesn't happen in a mask. The masks that they were talking about were the highest grade of surgical mask. Now, in hospitals and out of hospitals, and in public transport, and in restaurants, and in supermarkets, I have not seen a single person wearing those masks. People just wear conventional cloth surgical masks. And firstly, they do not trap anything significant. Well, I must say, I'm sure they reduce the rate of transmission. They might cut it down by, I don't know, 10, 20%, something like that. But if the virus is the size of a lentil, then the hole in a cloth face mask is the size of a railway tunnel. And it's bizarre to pretend that the one is going to trap the other. Not only that, but this is the important point, when people put masks on, there are clouds and clouds of virus, millions of them, that come billowing out past the mask. The masks don't fit to the face. Probably a third, possibly a half, maybe 3/4 of the air just gushes out past the mask. So masks, I'm sure that they have a discernible effect on reducing the level of transmission. But everybody's told in every country, make sure you wash your hands all the time because there's bound to be virus particles on your fingers.
You had mentioned on that program about washing with, I guess, diluted bleach and then wearing cotton gloves instead of latex. And that made sense to me because, you know, when you wear latex gloves, you know, you are creating a breeding ground if it gets under the glove because, you know, your hands get sweaty and it's hot and moist, you know. But I think you were suggesting that we're really more likely to pick it up from, you know, a rail we might touch or, you know, somewhere, a surface that we might touch, that we would be better served by wearing gloves than masks.
Well, we know that the official world accepts that must be the case because the one thing they keep telling everybody to do is wash your hands because you will have the virus on your hands. My view is terribly simple. If you wear cotton gloves, you know, the white thin cotton gloves that people use when they're examining old documents or jewellery or whatever it may be, if you wear those, then the virus can't contact your skin in the first place. And I believe that if people wore cotton gloves, you'd probably slash the rate of transmission enormously. Indeed, I published this as a rapid response at the British Medical Journal. You can see it on the BMJ's site. And yet nobody's followed it up anywhere in the world. And I think that wearing cotton gloves would be at least as useful and possibly more useful than wearing these masks. Masks cannot stop viruses. They can reduce them a bit.
I was persuaded. Fortunately, I live in an area of Japan where the infected rate has been pretty low. I'm in a rural location, and so there aren't that many people around here who've had it. But yeah, I was persuaded. I thought, I'm going to start wearing gloves. Let me segue. I told you I'm going to hop around a little bit here. Let's segue from pathogens to much, much larger organisms. And here's where you can shed some light on what I said in the intro about you primarily, but not always, being a microbiologist. In your 2019 book, Too Big to Walk, The New Science of Dinosaurs, why did you take on a topic of the largest animals that have ever been on Earth when you've been primarily concerned in your research with the smallest microorganism?
It actually occurred to me when I was 28 years old, and I took the kids to the National Museum of Wales in Cardiff, and they had a diorama, a display of model dinosaurs in a sort of a landscape. And there were these enormous great dinosaurs plodding about the place, and in the distance was a blue haze, and as I lowered my head, I thought, if that blue haze was water, it would make an awful lot more sense, because the weight of these massive dinosaurs would be supported by the buoyancy of the water. Now, ever since dinosaurs had started out, when they'd first studied them, they thought perhaps they'd retreated to water. They might lie in a muddy pool or something of the sort. But all the accounts of dinosaurs in all the books said they were terrestrial. And I thought it would make far more sense. You're not going to grow to 100 tons if it's going to be hard to move about on land, but in water it would be easy. And my friend said to me, you ought to publish that. It's quite an interesting view, the notion that giant dinosaurs evolved in water. And I said, yeah, but I'm rather like you said, Mark. I'm a microbiologist, so why would I publish anything like that? So I didn't. And I waited until I was in my late 70s, and I thought to myself, well, possibly now I should, because a program came on TV, one of these BBC science programs, where they had CGI dinosaurs, and they were describing their lives in ways that they couldn't possibly know. They were saying how the male dinosaur approaches the female dinosaur and utters signals to her to suggest that he's willing to mate.
During this, they rock back on their tails to impress potential mates. With creatures this size, the forces at work...
These infrasonic signals, and I thought, this is complete crap. Nobody has any idea of this. It's being presented as though it was reality. So I spoke to Miles Archibald at HarperCollins, and he said, we met and he said, yeah, that would actually make a really good book. So I wrote it, and I thought this will start a debate. Could 100-ton dinosaurs really have evolved on land, or was the impetus to evolve derived from the fact that they were developing in an aquatic habitat? And I thought to myself, that'd be interesting. So it was in the newspapers, and people said, here's a new view on how dinosaurs evolved. And then suddenly all hell let loose, because the world of paleontology just descended on me like a falling cliff in a rainstorm. It was quite extraordinary. And the language they used was terrible.
Yeah, I don't mean to cut you off, but in that book, you do acknowledge your critics. And I used the word controversy in the intro. And you even identify that there was a petition signed by paleontologists around the world and sent to the BBC after the BBC had broadcast an interview on this topic. And the petition read in part, "The BBC and everyone who carried this story should be ashamed."
Yes,
To which I guess the BBC replied, and I chuckled at this, "Brian Ford is unlikely to be put off by the condemnation of the established experts." And you wrote in the book, on that occasion, the BBC was right.
Yes, they absolutely were. But the point about it is, you see, that they must have evolved in an aquatic environment. Indeed, the eager podcast follower who might want to look into it further might look up aquatic dinosaur, one word, aquatic dinosaur on Facebook. There is a Facebook page on aquatic dinosaur. And all of the research that's coming out fits the aquatic evolutionary theory much better than anything else. The point is that there are problems which the paleontologists hardly ever allude to, but which are essential if you're going to understand whether dinosaurs are terrestrial or aquatic. The obvious one is copulation. The idea that a dinosaur, I'm sorry to chuckle, but the idea that a dinosaur that weighs 100 tons is going to be approached by another dinosaur equally heavy, and that dinosaur is going to mount it, and the BBC's simulation shows them shagging each other like dogs. I mean, it's really quite remarkable. And the dinosaur rears on top of its mate and crashes down. You've got hundreds of tons of flesh on these two rear limbs. I mean, it is inconceivable. But if they, of course, are in water, then they can copulate as easily as you wish, because the weight is borne by the buoyancy of their aquatic environment.
Right. Do you suggest, like, even T-Rex and Brontosaurus, that these were aquatic animals?
I don't doubt that they evolved in an aquatic environment. I think the way that it worked is that the big giant sauropods, like Diplodocus and the others, they would go browsing around in water, as it were, up to their shoulders, and endless shallow lakes covering the world at that time, and would graze on vegetation. And then when they died and rotted away, the T-Rex would come along and rip them apart and consume them. I don't see them chasing them at all, but just as it were, picking up the millions and millions of dead bodies and munching them to bits. And I have no doubt that that's the case. For example, one of the reasons why they can't really be terrestrial is because, although we've found hundreds of thousands of trackways, their footprints, you don't find any marks of a dragged tail. And if a dinosaur was a terrestrial animal, and I've seen the Komodo dragons, for example, in Komodo, and when you see those, their tails will leave a mark in the mud, and they're only, less than 100 kilograms in weight. But if you look at a dinosaur weighing 100 tons, then of course its tail would inevitably leave a mark between its footprints. But there aren't any tail marks between the footprints, which proves that the tail must have been buoyant. Therefore, they must have been in water.
Well, your view is in the minority in terms of conventional paleontology. My question is this then: can you talk a little bit about the double-edged sword of peer review in the sciences? In this case, the paleontologist critiquing your work. On the one hand, we need peer review as a kind of check and balance to test theories, but on the other, you pointed out in the book, due to the fear of losing credibility, or more significantly, losing funding, most conventional scientists will not embrace a revolutionary scientific theory. So in that way, peer review, in your words, peer review has become the single most pervasive obstacle to revolution in science. How do we do it then? Because if we don't have peer review, doesn't then that give, like, credence to theories like flat earth theory or lizard people among us?
Peer review has so many good things for it. I mean, there are people, an editor, after all, in a journal doesn't know what's good and what's bad. So the editor gets a paper and he would pass it to experts in that field and say, is this paper any good? And they might say, no, it's obviously wrong because that was disproved in the 20s or whatever else it may be. Or, no, he's forgotten so-and-so, it just doesn't work. I mean, a good example, a friend of mine early on said that the best answer to a virus would be zinc. And the zinc ion does indeed help to work against viruses. And so he's proposing that we should use zinc as an answer to all virus diseases. But of course, he's a chap who works on his own. And if you actually look into the literature, you discover that loads of people have thought of it, and loads of people have tried it, and it doesn't work as well as he thought. So in that sense, peer review has a lot going for it, because the caucus of opinion can tell you immediately, no, this is nonsensical for such and such a reason. But it does also work against novelty. You see, people get their grants for carrying out their research on their theory in a specific field. Well, if suddenly somebody comes along and says, everything that you've done is wrong, then they can hardly go to their funder and say, I'm sorry, all the money you gave me is a complete waste, and the research I've been doing is pointless. Their only motivation is to retreat and become defensive and try and at all costs defend their point of view, because that's where they get their funding from. So that peer review, although in so many ways it has such self-evident benefits, it is a fact that peer review prevents the dramatic quantum leap taking place in science. And an awful lot of science gets past peers because of the fact that it fits their theories and is wrong. Whereas a lot of interesting and novel science isn't going to see the light of day because the peers immediately refuse to accept it. So it's not going to appear in the journal. So it is in some perverse way a very useful tool, but also, in extremis, it is the greatest barrier to the publishing of new scientific theories that I've ever come across.
Yeah, I thought you made a really good point. I did see a speech you gave, an after-dinner speech to Cambridge students, and you had mentioned that the true innovators in science and technology, they were unconventional. They didn't go the path of, get your degree, go work for a company. You brought up Steve Jobs, Bill Gates, and you brought up some, I'm forgetting now which scientists that I don't know if it was Tesla or who it was, but you had brought up that the true geniuses and innovators in science and technology have really they went rogue, they went rebel, and I thought that was an interesting observation.
Pasteur was a chemist. Dunlop, who invented tyres, was a veterinary surgeon. Wherever you look, and indeed DNA, which was done so famously by Crick and Watson were told not to do that research because they had never seen any DNA, they never studied any DNA, they never worked with DNA, and they were told to bugger off and do something of their own. But they secretly looked at the data that they were getting from Oxford and London. Maurice Wilkins, who worked on it in London, and he died a few years ago, and was very bitter that nobody ever mentioned his name, because he did all the research. And they then took their results and managed to create out of it the structure of DNA. To this day, people say that they discovered DNA. No, DNA was discovered in the 1890s. What they did was to work out how the molecules fitted together to create DNA. And that was a great piece of research. But it was research they did in their spare time, and for which neither of them was remotely qualified. Most of the great steps in science and technology have been done by amateurs. Kodachrome photography was discovered by two concert musicians who used to carry around suitcases of chemicals and experiment in their hotel rooms when they weren't rehearsing. It's quite interesting to see the way in which the amateur is usually, the outsider gets a better view of the game. And it's the outsider who so often makes that great leap that orthodox academia can then methodically carry forward.
Let's move on to another book that you wrote in 2020, which was essentially a revised second edition of a 50-year-old classic. And my American pronunciation looks at the word and wants to say Nonscience. Off record, you had said that the British pronunciation was Nonscience.
Nonscience, yeah.
Nonscience,
yeah.
okay. Yeah. Nonscience, or How to Rule the World.
1971. I spoke to Peter Wolf, who was a great London publisher, and he published a series of books called The Bluffer's Guides. And so you have a bluffer's guide to opera and so on. And we met to discuss doing a bluffer's guide to science. And we had lunch in a very expensive restaurant in Soho, as one likes to do if one can swing it. And afterwards he said, this is a much bigger book than a bluffer's guide. This is really a serious topic you're talking about, the way in which science is bamboozling the public as often as enlightening them. So why don't you write a book on it? And I did. And it came out under the title of Nonscience, or Nonscience, as we call it. And indeed, it was very widely reviewed, and it's on TV. It was translated overseas. It had the world's longest publishing title, an enormous title filled with multisyllabic constructions, which I just invented. Actually, I wrote it as a joke for The Office. And when Peter saw it, he thought it was so brilliant, we'd use it as a title. But 50 years later, it turned out that the book had come true. The public really were being bamboozled by scientists. They really were taking literal truth, things that they really shouldn't. And they were also allowing things to be censured in a way that they shouldn't. I can give you an example.
Sure, I was going to bring up two, but go ahead.
No, you go ahead and bring yours up.
I know that you postulate among many things that the Amazon, for example, is not the lungs of the world, that it contributes no oxygen to the atmosphere. Is that correct?
Doesn't create any oxygen at all for the atmosphere that we breathe. When people look at a tree and they see it standing there in the Amazon, I go to the Amazon regularly, and you'll see people say, look at all this oxygen that's pouring out, can't believe it. And I say to them, yes, that's only when the sun is shining. At night, a tree in the Amazon breathes the same as we do. It breathes out carbon dioxide and it consumes oxygen. But nonetheless, by the time the typical tree has grown, it contains about a ton or so of stored carbon. Yes, but that's only by the time the tree has grown. Because what people forget about is that trees die of old age and then they rot away again. And so as the tree falls down and decomposes, every single atom of oxygen that it ever gave out is brought in again to convert the tissue back into carbon dioxide and water, which it started out as. So between the seed germinating and the majestic tree, you may well have a ton or more of carbon stored inside the tree. But by the time that tree has died and rotted down to nothing again, all the oxygen has been consumed. The oxygen in the air came from microbes billions of years ago. The carbon dioxide store is in all the rock that we see around us, the limestone. All those limestone and chalk, all those carbonaceous rocks, they're where the carbon dioxide is that has given us the oxygen remaining in the atmosphere. And it has been calculated that if you burnt everything on the surface of the Earth that could possibly be burnt, absolutely everything, it would have negligible effect on the amount of oxygen in the air. And yet people often talk about buying cylinders of oxygen to have at home because if the Amazon rainforest disappears, then we won't have any oxygen to breathe. It's a complete myth, but everybody seems to believe it.
The biggest living thing that exists on this planet is a plant. We depend upon them for every mouthful of food that we eat and every lungful of air that we breathe.
And it is completely and utterly untrue.
What about, you also say in that book that our hysteria about plastic is similarly misplaced. That why is that? I mean, that one, it's almost more controversial.
You get people saying they want to live a plastic-free life. Well, if you're going to have a plastic-free life, then you're going to have no hospitals, no computers, no schools, no buildings, no... Plastic is wonderful stuff. People complain that it doesn't degrade, but the fact that plastic doesn't degrade is its greatest benefit. That's why sewage pipes and water pipes and electrical insulation are made of plastic, because it won't break down, and therefore they will survive and keep us safe. If you make a plastic bag, then the amount of damage that it causes to the atmosphere is minute compared to making paper. The paper industry is one of the most polluting industries that there is.
You're not talking about Japanese paper.
Yeah, well, of course not. I am led to believe that some people actually hand make Japanese paper in the traditional fashion, which is an absolutely admirable thing to do. And no, it certainly isn't that. But the point about it is this, that people now go and buy a bag for life. You don't buy a little cheap plastic bag, you have a sizable bag. Half of the area of countries like Madagascar has been destroyed whilst they rip up the rainforest and plant plantations to produce sisal for the Western market. And the production of things like sisal is enormously polluting and massively damaging to the environment. It just makes people feel good. But plastic bags are so light that they cause very little pollution when they're manufactured. They cause far less pollution from transportation costs because they weigh 100 times less than a fibre bag. And the fact that they don't degrade means that the CO2 inside them never gets back into the air. So, of course, plastic pollution is bad news, but that's mostly caused by the kids. If you go and look on a high tide mark, and it's the stuff that the youngsters have thrown away that has caused the damage. And if you go to a protest area where you've had young people demonstrating like Extinction Rebellion, and what you'll find is hundreds of tons of plastic that they have thrown away. And then they complain about older people littering the world with plastic. No, it's the youngsters who do that, not the oldsters.
All right. Well, very interesting perspectives there. I really appreciate different viewpoints, and that's why I wanted to have you on the show, is because I know that you have a unique perspective when it comes to science, and I thank you for your time. As we wind down here, I usually do a segment at the end of each show called 5 Minutes Zen, and I try to offer a practical solution to the listener. So I don't tell them to go meditate on the top of a mountain or contemplate a koan, like the sound of one hand clapping.
Thank heavens for that.
And your response need not actually have to be related to Zen or meditation or anything like that at all. I try to tailor my questions for the interviewee. And many times that question will take the form of, how do you chill out, or how do you meditate, or how do you deal with anxiety in this crazy world of misinformation that we've been discussing, or the persistent news of doom, like artificial intelligence or pandemics. And that's what I usually do, some variation on that. However, I would like to borrow your intellect and experience for a slightly different practical solution. Here we go. Given your career filled with accolades and criticism alike, I would like for you to help us deal with our own critics. I mean, we can handle the accolades. It's the critics that give us a lot of trouble. Most of my listeners are not world-renowned scientists like yourself, but we all have critics among us, particularly in this day and age of social media and the internet. And for those of us ill-prepared, criticism hurts. There have been recent cases of young Korean celebrities committing suicide because they couldn't handle the abusive online rhetoric and harsh judgments rendered against them. Help us to become more prepared. How do you, on a personal level, deal with your harshest critics? And you've got a few. The paleontologists, for instance, who critique your work, or online comments that may call you disparaging names. How do you suggest we learn to deal with our own backlashes online and in life?
I have to say that the question of criticism arose after the dinosaur book, and in one respect it was quite refreshing. A lot of people said to me, you must be so wounded by the criticism. And I said, well, no, actually, I'm enjoying it, because throughout my life, I'd only ever had accolades. I only published stuff that was self-evidently sensible, and I only published stuff when I had found out the truth. I only lectured on subjects when I knew exactly what the subjects were, and I was meticulously careful to try and be honest and straightforward. When the dinosaur book brought about this torrent of abuse, I'd never experienced it before. The one thing I would say to most people who are listening is this: by and large, the critic is your greatest friend. If you do something, you're going to do it as well as you can. If you're going to make paper, if you're going to lay a table, if you're going to prepare a room for a guest, when it's done, you would think to yourself, I've done that as well as I can. So people who give you accolades and say, that's great paper, that's a nice table, what a lovely room, they simply confirm what it was you thought. But just suppose you have a critic who says, no, that paper has a bad surface, you need to do it differently. Or a person who says, this room is not properly organised, you haven't set out a towel and a flannel for your guest. The person who criticises is the only person who can possibly encourage you and show you ways to improve. People who give you accolades merely confirm your own impression that what you did was fine. People who offer criticism will show you ways in which you can improve. And proper, sensible, objective criticism, even if rudely expressed, is usually the only way in which you're ever going to find you can improve. So if people do criticize you, consider it carefully, because they may be pointing a way in which you can do things better in the future that you never did in the past. Anybody who's actually insulting is simply doing nobody any favours and certainly not themselves. But people who offer you criticism will allow you to improve. So just remember, your critic is your friend and not your enemy.
Awesome. Well, that is good advice. I appreciate that. It is practical. Well, Professor Ford, where can people get your latest book, find out more about you, and what are you working on these days?
Oh, goodness. Well, the problem with being, as you put it, world-renowned is that whenever I'm researching any subject I'm interested in online, it keeps directing me to my publications. And if anybody wants to search for Brian J. Ford, just pop it in the web and there I'll be. So far as working, well, I shall be lecturing widely in America and around in the Mediterranean. I'm pretty well fully booked for lectures for the later part of 2022. I'm hoping to do a book on the research I've done into Leeuwenhoek, the microscope pioneer, and I have a column in America called Critical Focus in the Microscope Journal, and I'd quite like to see a book of all of those articles appear. So we're discussing that at the moment. So although we're surrounded by pandemic strictures, life here is as busy as it ever was. And the fact that I don't have to go to places, but like now, can talk to people online, saves me an awful lot of checking in, an awful lot of travel, and an awful lot of heartache. It would not be true to say that I am not looking forward to the pandemic ending. I am. But it would be true to say that being confined has brought some very useful benefits that I greatly appreciate.
Well, that about wraps it up for this one. Professor Ford, I want to thank you very much for your time and your fascinating, intriguing perspectives. I'm very grateful that our paths have crossed. And we only scratched the surface today, by the way. I didn't even get to AI or spontaneous human combustion. So we got a lot more to discuss in the future. But thank you so much. It's been a blast. I really enjoyed it.
No, my pleasure. It was a great honor to join you.